In this video, we're going to continue topic 10.1, and we're going to look at example 5. So in example 5, we need to determine if the sequence converges or diverges. So basically, does it have a limit or not? So in this first one, I'm going to set it up against the limit as n approaches infinity of 2 over n, or 2n over 1 minus 3n. And if you remember back to AB, we know that we can take the limit of as we approach infinity, and we kind of ignore the constant as long as these exponents are the same and the limit is the number in front. So we know that the limit would have to be 2 over negative 3 or negative 2/3 because we're approaching infinity. We could also use L'Hopital's rule if you really wanted to on that. Looking at B is a little bit trickier because if I try to put the infinity in there, I get pi times infinity, and we know that that's not quite right. So let's look at this one here a little bit closer. So it's really the limit as n approaches infinity of the cosine of pi times n. So if I started looking at this, let's just start plugging terms into it to play with it a little bit. So if I look at my first term, it'd be cosine of pi times 1, or just cosine of pi. I know cosine of pi is negative 1. If I looked at the second term, cosine of it would be 2 pi. Cosine of 2 pi would be 1. If I looked at my third term, it'd be cosine of 3 pi, which would be negative 1 again. If I looked at my fourth term, it's the cosine of 4 pi, which would be 1. So do you see how the signs are alternating? So the alternating would mean that the limit does not exist. So we would say that this does not exist because it's alternating. All right, looking at C, I'm going to find the limit as n approaches infinity of negative 1 to the n over n squared plus 1. So we talked about earlier that this negative 1 to the n is meaning that the sign is going to alternate. So it's going to alternate between positive and negative 1. If I think about plugging infinity into the denominator, it would mean that I'd have infinity squared plus 1, which is just infinity. So either plus or minus 1, doesn't matter which one, divided by infinity is still going to be 0. So this would be that it is equal to 0. So, I'm supposed to be saying if it converges or diverges, aren't I? So this one here on A, because we got a limit, this one converges. This one here we would say diverges. And this one here we would say converges because we got a limit. All right, looking at D, I have the limit as n approaches infinity of 4n cubed over n cubed plus 1. Again, I'm noticing I have the same exponent, so I'm just going to look at the coefficients in front. There's an invisible one in the denominator, so I would just say 4. So since I got a limit, I know that this one converges.